Hello, so in this video, it's going to be quite mathematically involved, okay? Quite a lot of algebra and stuff going on, but we're going to try and come up with the equation of the best possible regression line, okay? The best possible line of best fit that we can come up with, okay? So like I say, it's quite mathematically involved. It's not necessarily something that you need to know how to do, but I always think when you're dealing with things like this, if you want the best possible concept in your head and if you want the best possible grounding and understanding, it's always good to try and kind of follow these things. So even if you're not necessarily able to do it yourself, it's always good to kind of see where things come from. And you think, oh yeah, I can kind of follow that bit and I can kind of see where that thing comes from. Because number one, it gives you more of a grounding in the mathematics and it gives you more confidence when you actually come to use it. But I think also as well, it kind of practices the skills and the techniques which you need to often call upon when you're dealing with mathematics. So all right, let's have a look at the problem then. We want to minimize this thing, okay? So remember, we want to look at these residuals, where the residuals are just given by yi minus y hat I, okay? And we simply want to minimize these things, okay? And we said we had to square them to make them all positive, add them all together, and whatever that final answer is, we effectively want to play around with different lines of best fit. You remember I was doing that on GeoGebra, and try and make that final sum as small as we possibly can, okay? So, where to go here then? Where to go here? Well, I think first of all, let's just do a little bit of algebra with this, okay? So let's take yi minus a minus bxi, so this is what we came up with in the last video, all squared. And let's just do a little bit of algebra with this, okay? So first things first, all I'm going to do is I'm going to keep the independent and the dependent values together. So in other words, I'm going to keep these two things together, so the xi and the yi together. So I'm just going to rewrite it as the sum of yi minus b times xi minus a, okay? So the reason why I write that together is so then I've got my sort of things which are changing, if you like. My variables are kind of stuck together then. Okay. Now, I guess first of all, a sort of sensible place to start is to consider the square. Okay. So really what I've got here is two things which I'm kind of adding, in this case subtracting from each other. So if I consider that as one thing, in other words, my variables, if I consider that as one thing, and if I consider my a as another thing. So my a is, remember, the thing which I'm trying to come up with. Okay, so my line of best fit, or my regression line, is a plus bx. So I'm trying to come up with the best possible value of a and b. So, okay, I guess we could just expand this. Just remember that if you expand two things out, which you add together and square it, or actually I could, because we could change this to subtract if we wanted to. There's a subtract in there, okay? Then we have, this is going to be p squared minus 2pq plus q squared. Okay, so that's what it's going to be equal to. So literally I can just follow this idea and expand this out nice and easily. So I'm going to keep the sum the same. I'm going to keep the brackets the same, but all that's going to happen is I'm just going to expand out that minus that squared. So the yi minus bxi, that's my p if you like. Then I'm subtracting a, and that's my q if you like, and I'm squaring it. So I should get this thing squared, so yi minus bxi all squared. Then minus 2 times p times q, so minus 2 times by that thing times that thing. So I'm going to write that as 2a times by yi minus bxi, okay? And I'm going to have to add on my q squared. So I'm going to add on q squared, which is going to basically be a all squared, okay? So that's what I've got at the moment. You notice that I've still got the brackets around all of this thing because I'm still summing all of that together. Okay, so that's the only reason why I've got the brackets around the whole thing. But literally all I'm doing here is just expanding those two things out when I square it, okay? Now, just to make it a little bit easier for myself, I'm going to go through and I'm just going to write the sum. So I'm going to distribute the sum over every single term, okay? So let's have a think. Well, the first thing, I just get the sum of yi minus bxi all squared, okay? So the sum of that thing, all squared, okay? And then I get minus 2a times by this thing, yi minus bxi, and then I have to sum all that together. Well, fairly obviously, the 2a is just a constant. Okay, so because it's a constant, I'm just going to have minus 2a times the sum of yi minus bxi. Because that's effectively the only thing that I'm adding together, and the 2a doesn't affect things, it's just basically a multiplier. Okay, so I just get 2a lots of that sum instead. Now I've got to be careful on the last one, right? So the a squared. If I add together lots and lots of a squares. Now a squared is just a number. So I'm just adding it together, a squared, then another a squared, then another a squared, for every single sum that I do in the other two things. Okay, so for every single sum, I'm going to add on an a squared. So in total, I'm going to add on a squared n times, because there's n data values in my sum. Okay, so because I'm going to add on n lots of all of the other ones, right, then I need to add on n lots of a squared. Okay, so I'm just adding on n lots of a squared. Okay, cool. So this thing here doesn't look very helpful at the moment, but trust me, it will fall out nicer. So, okay, let's focus my attention on this thing here for a little bit. Okay, so just for the time being, I'm going to come off at tangent. Okay, I'm literally just going to focus my attention on that thing there. So I have negative 2a times the sum of yi minus bxi plus n lots of a squared. Now, just because I'm sort of this way inclined, to make my life a little bit easier, I'm going to say that thing there, that sum there, it's just going to be a value, and I'm going to give that a name. Now, because it's a sum, I'm going to call it s. Okay, so I'm going to say this thing is s. So I've got 2a times by s, and I've still got plus na squared. Okay, so I've literally just said that thing there is just s. So sum of yi minus bxi. That's all I'm doing. And it's going to make my life a little bit easier. Okay. Now, just because as well I don't really like starting off on a negative, I'm going to swap these two things around. So I'm going to say I've got na squared minus 2as. That looks a little bit nicer to my mind. Okay. Looks a little bit nicer. And also, if you have a look at this, what type of equation have I got here? What type of equation have I got? Well, I've got an a squared. Then I've got an a. Remember, a is my variable in this case. A is the variable which I'm interested in. I'm trying to minimize this variable. Okay, so therefore this is a quadratic in a. It's a quadratic in a, and you might be able to see this a little bit better if I write this as na squared. So n there is just a number, times it by a squared. That's the variable, minus 2sa. So that there is just another number. So I've got a number here times a squared minus another number times a. Okay, so what could I do here? What could I do? Well, what I'm going to do, I don't really like the fact that I start off with a non-monic quadratic. So in other words, a number in front of the a squared. Okay, because it looks a bit like 2x squared plus 3x. Okay, I don't like that number in front there. So what I'm going to do is factor out that number. So I'm going to factor out that n. Now think about it. At the moment, I've got an n in that term, but I haven't got an n in this term, in the 2sa, right? Except I kind of have, but it's hiding. Because it's hiding in the sense that it's n over n, right? Because n over n is just 1, right? So it's just n over n. There is an n hiding in there, but it's just n over n. So what I'm going to do is factor out an n. Okay, so I get n lots of a squared minus 2s over n times a. You happy with that? Because I've taken out an n out the front of each of these two things. Okay? Okay, good. So, right, let's just focus our attention then on this bit in here. Let's focus our attention on a squared minus 2s over n times by a. Now, what could I do with that? Well, I could, if I wanted to, complete the square. Right? And you might say, well, why are you completing the square? But trust me, let's just go through with it. Because then I've only got then there's a nicer way of writing my quadratic. It might be easier to solve. So let's complete the square on this. So I get, well, just remember, if I complete the square on something, for example, if I have x squared plus 4x, something like that, okay, which is literally same as what I've got here. It's just a squared and a instead of x and instead of x's, right? Therefore, this would become x plus, then I halve that coefficient to become 2, square it, and take away the square of that coefficient. So I literally look at this coefficient here, I halve it, that's the number that goes here, then I square that, and that's what goes over here. So I've literally got to do the same thing. I'm going to say this is minus, so a minus 2s over n. I'm going to halve it, I'm then going to square it, and I'm going to take it away. So I'm going to take away 2s over 2n all squared. Okay, so that's what I've got inside the brackets at the moment. So this is literally just that bit there at the moment that I'm considering. Okay, that's literally just that bit there which I'm considering. So let's tidy this up just a little bit. You notice I've got 2 over 2. Well, 2 over 2 just cancels to 1. So I get a minus s over n all squared minus, well, this is going to be s squared over n squared. You happy? So s squared over n squared, because of course the 2's cancel, right? So I'm just going to be left with s over n, square that, s squared over n squared. Simple. So I'm going to put this back inside my bracket now. Okay, so I've still got n times all of this thing. So I've got n times by everything which I've just found. So a minus s over n all squared minus s squared over n squared. Now just remember before I get too carried away with myself, I said that s was equal to this sum. So I'm just going to replace this sum back in here. So I'm going to replace this with the sum. I'm going to make myself a little bit more space actually, so I'm going to write it out again. So I'm going to replace this with a minus the sum, which is the sum of yi minus bxi all squared, all over n, and I'm going to square all of that thing there. So I'm going to square all of that inner brackets. Okay, I'm going to make my big brackets around the outside slightly bigger. Then I'm going to take away, well, I've got the sum of yi minus bxi. I'm going to square the entirety of that thing, so square the entirety of the sum. That's all over n squared. And I'm timesing all of that through by n. Now in actual fact, because I can make my life a little bit easier here, I'm going to multiply through by n. So I'm going to take n and I'm going to multiply it by this thing, and I'm going to multiply it by this thing. So just for the sake of simplicity, rather than writing out again, the n comes in here and the n comes in here. Okay? Now clearly you can see that I've got a slightly simpler thing here. So I've got, let's have a look, I've got n times by a minus the sum of yi minus bxi all divided by n, and the whole of that bracket is being squared. Then I'm taking away, now be careful here, I've got an n and I'm dividing by n squared. So this n will cancel with one of the n's which are being squared. So in other words, this is just going to be 1/n of the sum of yi minus bxi all squared. All squared. So the entire sum is being squared. So in other words then, I've got all of this thing here. I'm just going to copy it. And I'm going to put it back where I came from. So all the way up here, that thing in blue is actually just, so let me write out the first bit again because I don't want to lose that. yi minus bxi all squared. Then the thing in blue is just simply that thing there. So let me make it a little bit smaller so it fits a little bit better on the screen. It's quite a long thing. Let me just make it a bit smaller again. A bit smaller again. Let's just fit it in there. Of course, I'm just adding that because that's all positive. Okay? So this is now the blue thing. That's literally what I've done with the blue thing here. Now you're probably thinking, hang on a minute, like think where we came from. How is this possibly better? How does this possibly help us? Well, let's just pause for a second. Remember, all of this thing is the sum of the squares of my residuals. I'm just doing a lot of algebra and I've written it like this. It looks much worse, but trust me, there is a reason for writing it like this. There is a reason for writing it like this. Namely because now I've written it as 3 individual terms. 3 individual terms, okay? So what I'm trying to do, remember, is try and find the values of a and b. So let me write this down. I'm trying to find values of a and b which minimize. So I want to make this value as small as possible. So I want to minimize the sum of ri squared. I want to minimize the sum of ri squared. That's my goal, okay? So let's have a think. I've got 3 terms here. Let me color code them. So I've got red, that's my first term. I've got, let's use green, that's my second term. And I've got one in purple, this term at the end here. Now have a think, just look at this. If I want to make my value as small as possible just by using suitable values of a and b, I can see a value which I can use for a, which is going to make one of these terms disappear. And it's the green one. It's this value, it's this term here. Okay? So if I look at this term, so at the moment I've got n times by a minus the sum of yi minus bxi divided by n, and I'm squaring the entirety of that. Okay, so I've got that term there. The rest have still got b's in, so I can do something with the red and the purple term. But at the moment, let's just focus on the green term because I can make that term disappear. Right, that's the only term which has got an a in, so I can choose a value of a which will make that value of that middle term disappear. right? And the term is going to be when these two things are equal to 0. So when the inside thing is equal to 0, right? So in other words, I can do that by setting a equal to the sum of yi minus bxi, all divided by n. If a is equal to that, then literally I'm saying that these two things, this and this, is going to be the same. Of course, I'm subtracting them. I'm subtracting these two things, right? So if I subtract those two things from each other, they go to 0, square 0, still 0, times it by n, still 0. That term there drops out. Remember what I'm trying to do? I'm trying to make it as small as possible. So getting rid of an entire term is a really good way of minimizing this thing. Now the reason why I can do that is because you notice the red term and the purple term doesn't have an a in. So I'm just trying to choose a value of a and b. So I can choose a value of a because that's the term which the middle term has the value of a in. If I use the value of a is equal to that, I've minimized. Okay, I've minimized. So let's just do a little bit of rearranging because I can do a little bit more work with this. Okay. Would you be happy that on the numerator I have the sum of yi minus b lots of the sum of xi, and I'm dividing all of that by n. So what I'm literally doing here, if you like, is distributing this sum over the bracket, and the b is just a constant. That's a value that I need to choose later. Okay, so we're not there yet, but we will get there. Now have a look. Clearly this is a fraction and I'm dividing by n. So in other words, I can say this is the same as sum of yi divided by n minus b times the sum of xi divided by n. Now have a look at these two things. Have a look at this and have a look at this. This here looks really, really familiar. Namely, isn't that just a formula for mean, right? So if I say y bar to you, you should recognize that that is just simply sum all the y values together. In other words, sum all my sum my dependent values together and divide by the number of values that I've got. So that there is literally just y bar. And likewise, if I said x bar, sum together all my independent variables and divide by n, right? So that there has got to be x bar. So in other words, I can say that a, the value of a, should be chosen by taking y bar, which is the mean of all my dependent variables, and subtract b, remember we still haven't found b, but we will later, okay, times by the mean of my independent variables, times by x bar. So there is the choice of values for a. So a should be equal to the mean of my y variables, so my independent and my dependent variables, subtract b times the mean of my independent variables. Okay, so that's how I choose a.